Hello guys. Welcome back to more of this stuff. G-Lang programming again. I got it all to work now, so it is able to compile, like unlike last episode. So now we're able to work on the algorithm stuff, which is what I'm working on right now. Pair.pair? That doesn't work for pair? This is spaghetti code, by the way. Let me explain. So we have an array called pairs for pair check, which is a struct made of just a single U short. Technically, it can just be not this. Anyway. So pair.pair doesn't want to do that, and it also, if I remember correctly, we're gonna have to cast this to a U short because something. But maybe if I go for each pair, right? Because yeah, oh, maybe for each pair.pair of pair. Well, pair is just a fucking. So we start off with pairs. We get pair. Then we have pair.pair. Which is kind of an issue. Because now I have to be confused. Pretty sure. Pretty sure. Okay, I'm just checking something. For each pair dot pair of pair, because we create for each of pair from pairs, then we use an if pair dot pair equals pairs, the integer c of pairs, which is 0, and then we use the value equals value times 2 for the value of pair, which would be pair.pair equals. But whenever you create a for each loop, right, the value is the range, like is an index of the range that you're selecting. So for each pair, if pair.pair equals pairs c, then the value of pair. Well, wouldn't it be for each value of pair dot pair, right? Or am I confused? Because it would be like for each value of pairs of this iteration. Because pair.pair should correspond to the pair of pair check, which is a struct. So that would make sense that it would work as pair.pair. I'm not sure why it doesn't work as pair.pair though. Oh, you know why? Because I put a comma there. Got it. I know where it's at. I think. Oh, shit. Pair of pair.pair equals pair, pairs, pair, pair, pair. This is the most legible code of all time. Alright, so cannot input. That means we need to cast to a U short. So what you do is on this side, you declare that as cast U short, and then put chew in a this. Don't ask me why that works, but it does, and then do 0x0, because I like to do everything in hexadecimal now to make it even less legible. Alright, so then it has type 2. Cast int val2. How is that an int? That is not an int. Do they both need to be casted as a U short? Because it's still trying to multiply. Maybe the cast and everything needs to be inside of parameters, so it doesn't have that issue. I had it working earlier. It was working fine earlier. It could also be that I need to declare a constant and have it as a constant. Could also be that I don't have that like that. Remove the outside ones. See if that does it. It's an int? Wait. I think it's just because that's an int. I think that will... that does not work. When does it hit this problem, though, where it has that issue? Maybe it's just that I have that in there? Cannot implicitly convert expression, cast int val times 2 of type int. So I should probably just do the whole thing. What if I cast this entire thing? That should do the trick, right? I don't know how that works, but okay. Well, we've gotten somewhere with this. Pair check. So we have 2 pairs of the same numbers. We want to take those numbers and we want to be like, alright, we have 2 of the same, multiply them by 2 and get rid of the originals. That's why I have a U short as well. So that way I can store the length, so it doesn't matter in the binary file that we're going to make after this. Pretty much all of this is going to be saved to a binary file after we run the pair check algorithm. That's for just the training side of it. But it doesn't append yet because I haven't added an append for the val. So it creates a val and then it needs to append the val and then remove this. So that will go in here. Pairs of C, and then it needs to append to vocab. Pretty sure that will work. Okay, that did work. But it didn't do what we expected it to do, because what it did was it went 56 and 22. Oh, found a pair. It checks it against itself. So we need to add a case or like a handling for that or something. We need to add an and statement to make it so that way if pair.pair equals pairs dot or pairs C dot pair. Oh, you know that, yeah, it's checking itself. And the index of pair dot pair does not equal pairs. So like the index of pair does not, I guess it does not equal, but we don't have a way to reference the index of itself. Because basically what happened is they all checked themselves, I think. So it was like, oh, I found a pair. Oh, I found. We can check that actually. Let's verify that. Verify is something we should probably do. So yeah, we'll need to add right lines for each of them. Right ln, which is going to be the pair, and what the hell? Why did I need to do that? Did not need to do that. And then pairs. Let's give myself a chance of figuring out what this could be doing. And then do that same thing under this one. So we want to get an idea of what the value is, so we want to write ln for the value. Write ln and then do val and semicolon. Alright, so 28,111. Let's write the truth statement, actually. Yeah, let's do that, actually. Because it will just write the line of the value of the statement, which should be Boolean. True, 28,111. True, 28,111. True, and 162,191. So it correctly identifies when it's found a match of itself. I suppose that's what we were looking for. Kind of. But we were looking for more than that. We were looking for a step beyond just finding a value of itself. We're looking for just itself, not like, or not just itself. Looking for other instances of it besides its index. So the algorithm kind of works, but we have to figure out how to make it so it doesn't identify itself. Plus, it needs to remove, set to 0, whatever pairs C. I guess we need to figure out what the index of C is as well, which is on the X outside. Write ln for C. I does not equals pair dot length, and C does not equal pair dot length. That should probably be an OR statement, because the second one of these is not true. It won't work. Pretty sure OR is just 2 pipes. Index of 3 is out of bounds for array length of 3. How'd that happen? Oh, right, so it tries to... I have no idea what my code even does at this point. I need to rewrite it. Bro, my brain is cooked after that. Bro, I don't even know how to get this to work. So we need to find instances of a pair. So we create a pair check, which is which happens up here. We create pair check. And in the code, that creates that... This creates the ushorts that we need for the actual bin file. So when we write it to the bin, it needs to be that. The next step is to, like, figure it out, you know? But we need to do a for each loop to take each pair of pairs. That's the first step. That makes the most sense, because you take the for each loop, for each pair of pairs, check if any of the other pairs equals it, and then if... So, like, essentially, what we need to do is go through it. So, first we do the for each pair of pairs. which will check each pair of pairs. If the pair equals any other index or any other pair, is there a way we can check that? I think there might be a case where you can check that. Maybe it's lambda. Maybe I just need to fucking search for the answer. Oh my god. Lambda usage. I think that's what I need. D supports two main syntaxes for lambdas. Lambda functions are short functions that liberals that allow embedding anonymous functions directly into expressions. They are syntactic sugar for creating delegates, closures, or function pointers. Primarily used to avoid defining name functions or simple one-time operations. Okay, maybe I don't know what I need. But I know that they don't have it in the standard algorithm library, which is what we probably should look at for this sort of thing. Also, this goes in BPE. So how does it work without all of this? That makes no sense to me. For each pair of pairs, and then we need to probably save the pair check of the next pair, right? I think we can do that. Or we take the U short of the next pair, right? So I think it's possible to do such a thing as take the U short array pair from the pair.pair. So like if we do a pair last pair last equals the pairs.pair or pairs 0 dot pair semicolon. So that's the pair last, which is going to be basically the first check. So if we check the U short array, and if any of for each pair, right? So that means that it starts at the first pair and checks for instances of the other pair. But I think it would be easier to do it in a for loop, right? So we would start with this in the we'll do it int I, and I want to avoid declaring that inside of the loop because I don't feel like doing that. Plus, this will be an output probably, potentially. And I think we want to do like I does not equal pairs dot length -1, right? So that's like the most logical case I can think of how to do it as. Make sure we put that all in a block just to make sure it's fine. And then do ++ I. So that will create an iteration for as long as pairs.length. Then we'll check each pair against the pair last. When it hits the end of the execution, boom. So every time it hits pairs.length until it equals pairs.length, we set it equal to 0. That's an idea. That way we iterate through the entire range and check each one. We'll create an if statement, call it if pair last equals. Well, here's something else to consider, is that we can check each pair against the pair of I.length, kind of. Well, there's also some other ways of handling this. For example, if we have an int for C as well, int. So I is the main one, but we have a C, plus plus for C, and that's how we can determine what characters are what when we put it together. So we could declare an int for C as well. Might even just do it inside of the scope, or attempt to. I'm not very good at doing it inside of the scope, so. Alright, so that should create our int C. Is that wrong? Am I wrong? I think I'm wrong. Because I think it goes semicolon after the scope. Maybe 2 semicolon? What is the problem? Because that's how you do it, I mean. Alright, that's good. So that's how you do that. Then you do int, or no, yeah, you can do int probably, but you'll do an if statement to check if it hits the iterations. If C equals that, then you do a plus plus for length. If C equals pairs.length. Then you plus plus I. That creates the iterator. So that way it checks all of them. Because the way that works is like, essentially I'm saying, do C until it equals pairs.length. Then increase I and set C equals to 0. And then restart that whole process. Now, all I have to do is add a... I don't know if I like this declaration in here because it's like fucking weird as hell. Is there good, like... I need a refresher on that, honestly. For loop dlang multiple declarations. Bro, this is for each loop multiple declarations. Hell no, we're doing for. Variable declarations, I guess, maybe? I mean, that looks simple. Like, it's supposed to go in a scope, though. Pretty sure it's supposed to. Yeah, that's wrong. That's definitely wrong. Unless it goes... I don't like it being yellow, though. Fucking hate that it's yellow now. This is a correct line, guys. I swear. Well, we'll find out how correct it is when I go to test it. So yes, now we have the if that statement, then do this statement, and then we need to create another if, which is going to handle the rest of it. And that's going to be to say that if the int I, which is what we're checking, the pairs of pair I, pairs array I dot pair equals, which is basically saying that it's a single ushort array, the pairs C dot pair, and then boom, boom. Then execute this code where you set the pairs of C to that and run a for each loop for all of those. Pairs dot pair C equals 0x0, 0. And it will probably be like, that's an int. We might need to cast it, so I'll be ready to cast. The pairs I dot pair should equal itself times, or yeah, itself times 2.
Oh, for each instance.
Yep, that's how it's gonna work. Self times 2. Could I do it times equal? No, I don't think you can. I think that works. Alright, so the variable name expected after int, blah blah blah. Not int. What do you mean, not int? So wait, integer I. Does that work? Does that work? Does that work? Oh, okay, so it ended up fucking up the loop. Alright, that fixed it really quickly, and then assignment cannot be used past the condition, as perhaps equals is meant. Oh. Right, where did I use that equals at? Equals. And then pairs cannot do the times 2 on a ushort. So you cast both to ushort. So you take the ushort of that. And it's probably going to be an array. So that has to be done as a for each. And then you do that. So for each val of the pairs of I dot pair then you do your maths. Val append value times 2 to vocab equals cast ushort, and then the expression val times 2 semicolon, and then it needs to continue, or actually needs to continue after that point, I think. Which is what I'm going to do, so that way we can get the expected result. Then it hits continue. So that way it only checks on one at a time, and it won't iterate C. Then it will re-begin the check for I. I believe that's how that works. It should put it back in that for loop. I love this. Index of 3 is out of bounds for an array length of 3. Let's see. But that was a good sign. So if C equals array length minus 1. Pretty sure that will work as that. It did something. Can I then append the val to vocab? Vocab append equals val. And then that's the new word that we've made. And it's going to write the line at the end. Vocab. I hope it works. I don't know what it's actually doing. Okay, so it picked them, put them in there, both. Either way, it needs to append the vocab to the val. Or the val to the vocab. So it found 2 instances of 2811, or 111. Added them up. Let's go ahead and copy this. That was better. It's closer to what I'm expecting it to do. True, true. So got 2 trues and gave us that. Looks like it does like 5 checks every time. But does it set it to 0? Doesn't set pairs of C to 0. So what is the value of pairs.c? Right ln pairs.c dot pair pairs c dot pair. Does that return anything interesting? It gives us 0. What is the value of C? DMD it. The value of C is 1. And that means that the value should be like... Wait a second, so the value of C is 0. Doesn't do anything, actually. Maybe after it finishes the execution of the program, it sets this pair. So after it checks for those and does all the... Oh, wait. That's just a for each loop for that. It should continue after that and then do this. Maybe. Closer? Kind of. Do a space, and then do a comma, and then do a pairs. Just write out all of the pairs, please. We'll need to see that. Pair check. Pair check made it 0 for that one. Ooh. Kind of what I'm looking for. Alright, so it found that one, it made it 0. But then this one still returns as that. I think it still is finding itself. So when it does that, it does need to have another. So we need to detect when it's checking itself. So that will need to be an AND statement for it does not. It's going to be like pairs I does not equal itself somehow. Or C does not equal pairs I. Because C iterates before anything. Yeah, it should be that. C does not equal pairs I. Or does not equal I guess. That doesn't work because then it would be like. It needs to be like checking the pairs I. Like. Right? Pairs I. Oh, and we could also just be like word ID. Pretty sure that would work. Or word position. Word pose. Could take the word pose of words I. Because this is what we're checking anyways. Pairs I. And then we're going to check it against C to see if that's actually right. Because that should be the struct word pose. Either case. Yeah. Though it doesn't like that. Expected another one of these. Did it expect another one of these? Ah, that's much better. Oh. No property word pose for pairs. Cast you long of type. Function pair check. What the hell? Struct pair check defined here. That's weird. Word pose is technically a thing that you can do. Technically a thing you can take out. But I think it's just that it is a that. So let's try that. Oh, did I save it? No property for word pose. I don't have a word position in there, bro. Right, yeah. Well, it's obviously not going to equal a pair check, so pair check dot word pose. Maybe I just misspelled it in the first case. No, that's not misspelled. It's an int though. Is the int? Yes, it is an int for that. I see. Pairs. So we have pairs. It's made up here from pair. Okay. Well, I can't take the index of it. I guess maybe and C does not equal I is the answer. If C equals I hope that works. Kind of. What did it do? Didn't do anything even. Did it even check them? Like it just added this, it did the same shit again. So I did not equal C. I could be doing this wrong. Instead, I need to be like comparing. Well, what if I could compare them all at once, right? Like compare them all at the same time and then return the result. That'd be an amazing idea, potentially. I think we restart again. This is not going well. The logic's wrong though. That's what we do know. C does not equal I, right? And it stops right before the end. Yeah, no, this is not going to work. This is too complicated. Let's redo that. Make it simpler. So we have our pair check array. We want to check to make sure that no pair equals another pair, which means we have to do it recursively somehow through a loop. Oh my god. I mean, I guess what we could do is take the first. What if I had like a fucking whiteboard to draw on, bro? Like if I had a fucking thing to sketch out my ideas in GIMP. GNU image manipulation program. Haha. Alright, so to explain what I'm thinking, we have so we have our like, what the hell? I thought it just defaulted to this. We have our array. Right, so we have this shit, and then we take an index of it. So like if we have like, oh my god, bro. If we have 1, 2, right? Then we check this against the second index, the third index, until we reach the end. And we take an index number out of this. So the inum comes out of that. And then, like, this guy is 1, 2, for example. We take the inum of each instance that represents it. Right? Like that. This one, for example, is like 6, 3. And then the next one is 1, 2. We'll take an index number from that one as well. Yeah, so we'll create a bunch of... Well, you can create an array of these inums. And that's how we then could represent that, is to add the indexes of each inum of the 1, 2. Then we take the actual value of it and add that to the same array. Essentially, we create a struct that contains the position and the original value of that specific type. So now I'm going to create a new struct. So instead of using a ushort called vocab, we will be using a struct to handle this. So the original ushort, or yeah, ushort, then can be stored like that. That will create a storage algorithm essentially. I really don't like creating 1,000 structs, but we're gonna have to create another struct called, what is it? Inum. It's like enum, but fucking stupid. So we're gonna take the integer of index and the value, or we're gonna take an integer of index array. indexes or indices and the fucking u short value, and then we need to put that into. God, that's complicated. But hey, it's gonna work. I mean, then we store it like that, which means that the original word position is lost, though. That's the problem, is that we're gonna lose the word position by doing that, unless we somehow quantumly entangle the bullshittery and then somehow get it to work. But that's not happening. I mean, you think I have the capability to do such things? Hell no. It's crazy, though, because we can't get it to do it the other way. Because I'm not sure how to use it or more advanced systems to do that. So we have u short value. Yeah, we could create the u short values. We add the index to it. I really want to get into just bitwise stuff rather than this. Working on this stuff. I make all these different fucking programs and I publish them and don't even maintain them anymore. I just like to make programs at this point. I mean, technically this would work, but I don't like that idea. All right, let's erase the whiteboard of idea thinking. All right. So that was an idea. We could have our thing so like if we take what is it? We have our array. What am I doing? How am I screwing this up today? Is it just really tiny? Oh shit. Maybe I should have made it like 16 pixels. Oh, okay, here we go. This is much better. That's way more better. So we have our array of like 1, 2. Then we have our next index, which is also 1, 2. It's an array of arrays still, though. That's the problem, is that we're handling arrays of arrays. We could handle individual numbers, though. See, we found this. And we found that, and then we could take their, well, we've already discussed that method, but what if how do we find them? Is like compare the first one to the next one to the next one, because we saw how that works. That doesn't work very well. So I guess the real question is, do we want to try a different approach to comparing them? Which I think, yeah, we probably should do that. But we know that these are here, because I can see those are there. So that's how we know they're there. If I was the fucking function in there, I would be able to go, oh, there's a 1 and a 2. It's something, yeah. But the computer needs to be able to do that. So 1, 2, we have another 1, 2, we have another 1, 2, and there's a 6, 3. We tried looping it recursively and checking this one against the next one against the next one. However, when you check this one against itself, it immediately registers itself. So the first check doesn't check any of the other ones in the recursive case of a recursive scenario. And trying to avoid that is pretty much impossible. So we take the first index of each of these and compare it to the... Bro, at that point, I'm dying. Hell no. Well, we could just create like another array to represent... like, what if we had like a conveyor belt? Like, imagine a conveyor belt, right? You had like the array is like a conveyor belt. Like, imagine that. If I could like slide an array, almost. I think I'm describing something that already exists as a capability, a technique. So like we would slide the index against the original array, and then check like that. So if 6-3 comes up here, but that's gonna be really sloppy. I feel like that wouldn't work very well. We could also try nothing. I don't even know, man. This shit's hurting my brain. Well, actually, we could take the first one, and instead of like doing an if statement, we do like some kind of modulus. That's not gonna help us. Could count the number of occurrences of this, and then multiply the original by 3. So for example, if we have 1, 2, 3, append this to the vocab. Yes, that will be, then we append it to the vocab, right? And we somehow get rid of this and that at the same time. And then we check the next one. So the first step is counting each pair. Let's try that. So we're going to create a uShort array. We're going to call it vocab. Alright, so that's our uShort array. And then the first thing we need to do is make a loop. We're going to do for each pair pairs. Then we're going to take the first pair as a uShort array. Also, that needs to go up. All of this needs to go up. Yeah, we'll take the first one as a uShort array. Is there a way to check for the next pair? I mean, oh no, we need to count instances of the original. Okay, there we go. My brain is working. Count instances of that. Now, if any of the... Oh! Holy shit, I just realized. We can count them and make the array vocab store an int, or count hold an int. Int array count semicolon. So instead of focusing on merging them, right? Like, we know there's going to be a certain number... Well, we know there's going to be multiple instances, or check if there's multiple instances, right? We create a count array. So let me explain what I just thought of. I think it's probably what I was explaining earlier, but it would be easiest to just draw it out. Drawing is easy, guys. I'm telling you. Easy answer to the problem. So, let's say we have that same array that we had before. Oh, 1, 2, and then 6, 3, and then bro, everybody can tell what I'm writing. Okay, 1, 2, and then boom. See, you can all tell what that is, right? So then first we check it, and then we go 1, 2. That's a new array, so that's 1. This one's 3, so we've counted that. Now we've assigned that there is, well, by the end of it, the count should be 3. And then we go, alright, well, where is there a unique number? Here there's 3, so we found 3 right there. That's whatever that index is, there's a lot of them. So we're going to multiply, take the original index, multiply by 3, so we get 3 and 6. Then we could get rid of these ones like I said before, but we don't need to. We know that it's 3 and 6. We can ignore these original ones that don't have, but it's going to treat them as a unique one anyway, and it would require some advanced handling. Okay, let's try that again. So we have the 1 to 2. If we can count them all at once, right? So we have, if we can get that number without doing any iteration, for example, let's say we have this, count it immediately, boom. We immediately have the count as 3. Check for 3 instances, boom, returns 3. This one's only got 1 instance, so boom, we have 3 and 1, which gives them unique identifiers. However, that's not good enough for what I'm trying to do. That's not gonna work out really well. But we can know what they are based on that. Brain pain, bro. So we want to count them, though. That's one thing I do know. Maybe standard algorithm has us covered with something. I did try looking for it last night, but unfortunately I didn't find what I was looking for in standard algorithm. Standard algorithm. Oh, hey, look, D programming language. Find. What does can find have for us? Or find? Used to locate elements or sub-ranges with an input range. Haystack. So it finds that. And then, oh, okay, that's much easier than what I was trying to do. So we need to import standard algorithm dot searching find. Then it does auto result, auto array, found find array, find an integer in an array. So find the array and then find instances of the first one. If that's what we want. So we're gonna import standard algorithm. Alright, so we import that, we import the searching. We're gonna look for each pair of pairs, find auto what does the return from that look like though? Oh, okay, here we go. Auto array 3. Why would it give you 3? Found equals find array and then 3. Returns 4 and 5. Using a predicate first elements. Do we want that? Man, I don't even know what I'm doing, bro. I'm gonna be honest, I don't know what to do next. Because I'm kind of lost, because I cannot think of what I need to do. So here we have 0x1c, we have 0x6f, and all of that's in the word immutable. Okay, it takes word immutable, which is that, and it's going to do the first part where it casts ushort word dot word. So it takes, oh, okay, it takes out the word dot word and gives us cars for it. The first step creates pairs into a struct called pair check, which contains pairs. Why do I use a struct called pair check to contain pairs? Because it's the way to store them, I think, right? Pair check stores just the ushort value. So I just use that instead of an array of arrays. Okay. So there we go. But we could implement the whole checking portion of it into like the first portion, probably. Like, we don't need to make a second function to handle all of that. I think it overcomplicates things, actually. If we just have pair check, then we can handle that easier when we return that to the next one. This appends the pair check to pairs. So then we create an array called pairs, and that holds all of the pairs it created, and it slides by 2. So basically what that means is that it creates pairs. It creates pairs of 2. That's all that it means. Yeah, creates pairs of 2. If I have 2 of the same elements, basically, I should merge those and create a bigger one. So we need to check. I mean, we already discussed checking them with like loops and shit. Doing recursive loops and trying to do that does not work very well, really. Because then we have to take 2 of those. So if it finds 2 2811s, what we could do is add the values of them and then try to merge them. Or we take the 28, handle it as a string, and append a 111 to it to get it to be that. Or, you know, because 28 and 111, we have to handle that somehow to get them to be easier to handle. That's the issue we're having. We need them to be easy to put together. And I suppose we could do that by no longer comparing each pair check equal. We just take the original values and put them together at that point, right? Because, you know, there's 111, right? Boom. 28, 111. I don't know, that's one way we could try it. I'm kind of stuck. 28 and 111. Why does it have to be so hard sometimes, bro? Count them up, right? We do have indexes, so we could take indexes of them. There's also another thing we need to handle, which is cases where the actual first index and the second index equal each other. For example, when you have a word that contains oo or e, as in double E and double O, that needs to be handled the same way, kind of. So if we have like 0x11 and 0x11, that needs to be handled as well. So we can handle that in this original loop for sure. If you have 0x11 and 0x11, you need to create one that has just a pair and it stores 0x11. But how do we do that then? So we then have pairs, right? So it creates pairs. And if we have our... Oh, well, let's also test that the 0x5f doesn't create an issue if we put a 0x5f at the end. Yes, it appends a 0. So when you have... The first step will be checking if pair check index 3, in this case, is that. For example, like... We could do a... We can literally do this so easy. So for each... And then handle pair of pairs... This is the easiest part, because this one doesn't require any of that sliding stuff, but we can detect that early and add the two together, be like, boom, and append that to the vocab instantly and be like, or just put that back into the pair it was. Alright, so if pair dot... So we'll take an if pair dot pair index 0 equals pair dot pair 1 equal, or yeah. Then you combine the two together and reassign it to pair. So you need to do pair equals... Or, yeah, pair dot pair equals the original pair times 2, which needs to be in an array, comma, and then 0x something. Also, that's in a scope. Why the fuck did I put it in a scope? Okay, and then put that in there, and that can't equal that, but we can put it equal to a 1 and handle a 1 for this file format differently. Reason we could do that as a 0, 1 is because when we do the read functions, it's gonna be, it's not gonna work if we do it like that. Cast... And then we're going to do uShort and array of uShort. I think that'll work. Expression expected, not if pair. if. That way it makes it simpler and allows me to store this in memory way more efficiently, because then we can be like, when we read it back, we have to be like pair dot pair times 2, and if it receives a times 2, it should already know what to do with that. It's gonna go, oh, we have a 2 times 2 in this one, where it's double. Let's divide by 2 and see if this equals an original character. Only issue is potential for collisions where that could occur. That's why I'm putting a 0x0 afterwards. If you all don't already know what I'm talking about, is that we put this into a bin format. We can actually handle these as like an opcode. Like think of that. Think of like a instruction basically. The computer can read this. Like our program tells the computer how to read this file, right? And it will be like, oh, I found this, I divide it, but then after it, it appends a 0x01, in which case I need to divide the original number I have just found by this. So if it's stored in a pair of 2, that gives us our handle to handle the other thing. Technically, we no longer need to use ushorts. However, the reason I'm going to use ushorts is because you can store more than 256 in a ushort. And in a ubyte, you can only store 256. So if we have a ushort, we store like probably like a square root 256, bro. That's a lot of extra tokens for our model that we're going to create at some points. So then we can be able to use the opcode after it in these arrays. Essentially, we're handling an int, but half the int is going to be... If you didn't know, I'll go ahead and pop open the fucking hex editor now for everybody, just to make sure everybody's aware of what I'm talking about and it makes sense. We go into DTools and we can go into V02, and it should be in dictionary, right? There should be a dictionary in here. No, I got rid of it. Fuck. Well, there is Fish AI V0, which should have a dictionary in there. Or the Fish AI tools? Yes. That's not the one I'm talking about. That opens without the hex editor. Dictionary.d. Dict tooling. I guess that's what we're looking for? Yeah. That is. So this is kind of what we're looking at originally, where it's using ubytes and then stores a null terminator. The null terminator will still be used at the end. Now, when we go to handle this as a short takes up 2 bytes. Or, well, no, it takes up 1 byte. This, 1 byte. However, the array, when it writes it out, is going to take up a total of 2 bytes. So each array is stored within 2 bytes of this data. Effectively meaning that every one of these can be a letter and some information about that letter. So the idea is, if we have 2 of these, or like for instance, this would become a... trying to think of what this would look like, but it'd become bigger than this number. It would be end in a 0-1. It'd be twice this number and end in 0-1. I'm pretty sure this is like 30 something. Correct me if I'm wrong, but it's probably like 30 something. Well, it is close to like the... no, it's definitely under the F for like a very long while. It's probably close to 30. Yeah, I'm sure there's a way to do a fucking hex easy. Decimal? Can you... Oh, 108? Oh, that's easy. 216, obviously. And each of these represents a car as well. So this would become 216 and a 0, 1 afterwards. Basically just putting a 1, 0, 0, 1. The next thing is... scrolling through this. Let's see. Oh, here's another instance. 222 would become... yeah, 222.01 would be in this case, 001. So that's what we want. That's the optimal scenario. The rest of this kind of all comes down to how the handling goes. What was the issue we had? We had a pair 2 and it cannot cast a... it's not determined for type. Pair check. What do you mean? Pair 2? Right? Yeah, do that. Incompatible types for ushort. Pair, and then the index 1. 0, it's 0, I guess? Right? That would work. I don't know how that works, but okay. And it should return without us seeing that. Yo, cheesy nab. What's up? Right, ln. Pairs. And then this. So that should return that to the original one. Pair. Okay, so that should be fine, I think. Test. it's still 17, 17 because it doesn't adjust the pair check. It should set the pair, this pair to that. I don't want to initialize another array to handle pairs. So that should just set the pair from the pairs equal to that. Right? I mean, let's just write ln. No, don't do that. Do it here, maybe? Pair. Dot. Yeah. Write ln pair before the end of it. That will give us a good testing point. Okay, we had something interesting happen. So it ran the pair check. Goes through the whole thing, and it does something. So we have 17, 17. And that is appended a 1. The last one's 95, 0 as 4. So we need to create another pairs array. Ah, yes. How amazing. I'm not nesting another fucking scope. Oh my gosh. But it won't adjust it. That's the thing. What if I put pairs of this one, like the pairs of this index? Like we need a count of it, I guess? A count? Like you count up how many times you do it and then be like, what number are we? This index equals... Right? So I put in int I and then do that, I guess? I mean, it's worth a shot. It's always worth a shot. And then we just do a plus plus at the end. Before we end the scope. Plus plus. Plus plus I, semicolon. Oh yeah, that will work. That will 100% work. So then we can do the pairs of I. That's the index. Dot pair. That's how we found the index. Okay, perfect. And that should have changed everything. 34 and 1. Boom. That doesn't initialize another struct. Keeps us within the bounds of whatever limitations I'm setting on myself. Now, obviously, you're not going to see a 34, but like if we had P, which is like, or no, K is like one of the highest ones. Pretty sure tilde is the highest one. Now, if you, like we discussed in a previous episode, you can write the, convert to UTF, right? And then write that out into a bin as a double, and that's like the largest size you can make for a character. It wouldn't be UTF format because it's got a bunch of fucking null terminators afterwards. But it will take up a lot of file space because, like we've been discussing, bin is very interesting stuff. Because each byte is literally a byte. It's a physical representation of what's actually in there. Like, you can actually quantify what is even there. It's not just a letter or a number or anything. It's like actually you can tangibly copy and paste what's there. 3 bytes. Wait, is this actually like stored as 3 bytes? Or is this just 1 byte, 1 byte, 1 byte, 1 byte? But then how is that 3 bytes? Whereas that's 1 byte. That's also 3 bytes? That's 2 bytes. Wait, how's that? What? So that's 4 bytes. I'm kind of confused now. I thought that this is a byte, and you add a byte to a byte, you get two bytes right here. That's 3 bytes right there. That's 4. So what, is every 5 of those? How does that work? Binary. Oh, maybe, oh, I think I understand. It just doesn't count it right. So yeah, that's 4 bytes. Yeah, so I'm right. Yeah. It just wants to highlight the one next to it with the cursor.
Oh.
So we've actually got that part's easy. To getting the 17 and the 17 to become a 34 and a 1 is easy. But the hard part's when we need to go check for instances of 2 different pairs. Because then you need to check every pair to make sure it's not equal to another. And eventually this will go into the BPE.D, but we just haven't gotten that far. Translate no. Easy peasy. Damn. Wait, how do people do this where they put translate on it and it takes no and makes it into easy peasy? What the hell? This is cool. Very cool stuff. So that's done. We can consider this part done. Although for each pair of pairs it checks that. Okay, so then we could do another for each? What? Well, it translates like your comment, like I hover over it and it goes from no to easy peasy. You want me to show you? Whoa. Don't show all of that. Easy peasy. What the hell? How does that work? Oh, somebody just sent me a message. Red Dat. Hacking computer nerd. I know what we'll watch. Get me karma. Get me lot of karma. Red at. Bro, this shit's hilarious. Some great stuff right there. Very nice. I don't know who sent me that, but thank you. Wow, no idea. Yeah, I'm kind of confused. Why you need to translate English to English? No to easy peasy? I mean, I think it's fucking hilarious that it translates to easy peasy. Into I. Let's see. So, we could just set like an initial check for like each index. Like, we need to iterate. Okay, so when we check, we need to iterate indexes. Reset if we okay, let's go back to the drawing board. This is clearly not it. So here's the drawing board. If you can't tell, this is an array of 1 2 1 2 6 3 and 1 2. And what we need to do is a few steps. We need to iterate that number. Find the instances of itself without finding itself. So the first step, we take this number, then we set that to 0. So we'd go, this is now 0, this is now 0, 0. Null, nothing there. Boom. So now we just have a 1 and a 2 in its own little thing, existing in its own little world, doing its own little things, right? Boom. That's what we're now checking. So then we can then be like, oh, there's another instance here. 1, 2. 1, 2. And get rid of those as well. But that's a little bit overcomplicated. Like it's, we could check if they're next to each other, but we need to check for recurring pattern, which is the 1 and the 2. We could combine all of them into one. So like instead of handling it all at once, we do 1, 2, 1, 2, 6, 3, and 1, 2. Then we handle each individual one separately. We go, alright, so we took the pairs. We found a 1, 2, right? We could also do an algorithm that removes the 1, 2 from it until it has no longer found any occurrences of 1, 2 to create a pair array that only contains one instance of 1, 2. Which I feel like is really overcomplicated, but would work. So we have 1, 2, 1, 2, 1, 2. Like, we obviously want to find all of those. They'll all be part of the same one. So we create our index first, right? So we're going to append all of those to it. That's what we'll do first. So we're going to make this. It's going to contain a thingus. No, not a void. Why would I create a void? A U short thingus. U short thingus, bro. U short hingus. That sounds like a insult. Like some kind of fucking Star Trek insult. And we'll call this car store. No, it's not descriptive enough. We want to keep it descriptive but vague, so let's call it a combo. Call it combo, right? That's a good name for that. Create our ushort array called combo. So I think the first step, we append everything to combo. So we'll do a for each to create combo and append everything to it. The for each will be pair, and then the pairs appends to combo. So we're gonna append that to combo equals, so append equals, what are we appending now? Pair dot pair. It's just like word dot word, bro. Alright, so that creates combo. Now combo is gonna get, what we're gonna do next is remove extra instances of pairs. And then redo the original first step, which is to create the pairs themselves. So we're going to check for other instances of the first. That's when things get complicated, is when you start trying to check the same array for one single thing. We need to I'm sure there's something in standard algorithm that can help us to remove the other instances of that. We could also put a function in the struct and then call that function, so that way it's like set this to 0 because we don't need it, or set it to null, make it not exist, destroy that specific part of the struct. But then that's still in the struct array, which is storing all of those. But for now, we'll just put a right ln for combo, just to see that it works. I just want to make some forward progress on this function. I'm not gonna lie, I'm definitely keeping this open for the next time we do it. Alright, that's what we're looking for. That's the array we can use to identify if there's multiple of those. We could now take a slice, or better yet, compare each. It'll be easier to manipulate combo than it will be to manipulate the rest of a pair of pairs, bro. Combo then needs to be like identify the pattern, or no, identify instances where there's two, and then check the rest of the array for those. So we could take do a sliding index, sliding index array, or a sliding slice, better yet, where it takes that and then it will check each one, increment it up, boom, and that will return the original word value. But pair check originally was just to create pairs. What's the point of pair check if it just like, yeah, what's the point of pair check now? It doesn't exist. We take, anyway, of doing this? I actually don't know anymore. Well, what do you mean, what is the purpose of doing this? Like, I feel like this isn't necessary anymore because of what I just did. Well, actually, it is necessary because I've used it in this part now, but I could rewrite that easily. That just creates the original index of 34 and 1. Or creates that data. So it takes the two 17s, which is probably these. Yeah, it takes these two 17s. Also, this handles an appending of a 0 to cars. So we could technically handle cars instead of pair check for pairs. Pair check just creates indexes that are easy to operate with, except that they're not, because that's not how that works. Oh, you know what we could do? So the U-short array for combo could technically check if the other pair exists, and then not append it if it does. That's the most efficient way to do that in this case, I think. So if we'll do an if statement, if combo does not contain that, combo does not contain pair, right? Yeah. How do you check if it does not contain? Or any instance of? That's what I really need, is like any instance of. Oh! Find any instance of a D-lang. Of a slice D-lang. If combo, then. If not combo? Are you sure that would work? Oh, maybe? Maybe that would work? I don't know, maybe. I'll try it out. If Well, we could do like if combo does not equal, or if not combo, then we also want to make sure that it's identifiable. Then it appends it, else then it will identify that it's been appended already by adding in another tag of some kind, which is kind of what it is. It's kind of like a tag. When we get this number here with the 1 from the 17 and the 17, that number is tagged with 1. I think that works. Okay. If not combo, then append. And that's this line here is combo. It only appended 28. Wait, so if not combo, combo doesn't have anything appended to it, right? So if we appended like... Oh, I think I understand. Okay. So it just depends. Oh! Holy shit. We can use this for something very powerful. And I've just realized what it is. I think you're getting me in the right direction with this. So instead, we can then check for instances of that now. So for each pair of pairs, do that. Creates combo. Boom. That means that we write the line combo. We can take this and use it to check for other instances of that same one, which is a good starting point. Plus, it's in a for each loop, so it can be looped again and iterated through again as needed. So then we do for each pair of pairs again. But that, I don't know if that's what I need. So it appends that to the appends pair.pair.combo, which means that combo. Oh, and also the way this works by default is it's doing a Boolean statement basically. Anything inside of these parentheses is basically either stuff for a function or Boolean. In this case, for if, it's just a Boolean by default. Which basically by saying not, if combo is not true, then it will do that. And once combo contains stuff, it is now true. But that does kind of help us get on the right track, because that gets us 28 and that number. We would take a slice maybe of what we have to check if it is not that. So we would, I think, yeah, we could do that. But then also, if pair does not equal any part of, no, that wouldn't work. Well, how did I get that to begin with, right? No, that won't work. I'm thinking too hard about it. That won't work. I mean, it did work, kind of, to get us that original value. I feel like I'm on the wrong track, though, from there. Because that won't work with the for each loop. We need it to append the stuff to combo. Alright, let's try that again. Check. Alright, so boom. But we can also do another one to check if the pair I think I can do that. Use short and call it the check. Check that. So for each pair of pairs, and it's going to do an if. It's got to be an array too. But then we'd have to compare it to a slice of combo. So it does if not check, append it to check. Then if it's not present in any slice of combo, which iterates. I hate iteration, bro. It hurts my brain. So if not check, then append to check. Or actually, no, check equals pair, and then boom. Then we can handle it in another statement. Write ln combo and check. Pair.pair. ./test. Okay, so it does give us that. So if it finds an instance of two of them, combine those two. Or assign a new value to them, actually. It's not combine two, it's assign the value. So like take the two characters and put them into each other. I don't like that idea. But we would assign a 2 afterwards. But it means taking it back from there is difficult because we'll need a dictionary that handles that. But that gives us the two things we need. It's combo and check. So then we can iterate through check combo using check. I think. So we would do a for each. And then we would also need an integer that handles... no, we don't need that. We could do that, actually. Int I. It's a lot of variables and shit. Then we do I plus plus. Or no, plus plus I, semicolon. Then for each value, or cut, slice cut, who cares? For each of those, from 0 to I, which creates a for each that does that, for until it hits the I value, and we're going to take a slice of 2 of indexes, right? So we're going to do combo like take a check of it, like if combo equals check. This is not to count it, but it's to assign a new value to it that's unique based on the value of combo. So if combo equals check, then it also needs to reassign check in that original loop. So if combo equals check, then set the value to 2 is the original value time with 2, or combine them together and put what their dividend is. Like, for example, 111 and 28. For example, so if we have 111 and we have 28, obviously that gives you 139. What are they divisible by? That gets you to 0. That's the real question. So then you could create a float from that to have a floating. Fucking hell no, we're not doing that. That's a bad idea. We're closer though. We're able to check if that's there technically. What does this say though? Slices contains or similar to search for an instance within a slice. To find an element in a D slice, you must typically iterate manually using a loop or utilize external libraries. Bro, no. Found equals true. Yeah. Find any, all. So find, I guess. For functional styles searching. We could do the if outside of that. Cut that, backspace, enter, Control V. I have an idea. So we iterate the for each after we conduct the check. Right? The check exists for one purpose. That is to create a check value. Oh shit. But we could create another for each loop and then put it all inside of that, I suppose. For each pair of pairs, who knows how well this is gonna work. The nested for each loop combo right here. Call it a combo meal. That's where the name combo came from, by the way. Oh wow, look at that formatting. So syntactically amazing. Check. Does that? That's so useless if you can't do it before. Obviously, we would want to do like a for loop then. Do a for loop and then take the index. Creates plus plus. I don't know. We've gotten ourselves a loop though. Got our check thing. Okay. I see. The way I think of it is, I want to do it all at once. Like, if I was gonna do a check, I kind of just want that all to happen at the same time. But I feel like I have the wrong mindset about that. Check for recurring values, then add them up and find the modulus of them. Then their positions need to be stored if you compress it like that. We're not trying to compress it though. We're trying to say that 28 and 111 are a specifically different value than, say, 111 and 28 if they occur commonly. So, like, the idea is, like, let's say I had, well, let's take, for example, what we have, right? We have 28, 111, 28, 111. It recurs twice, right? That automatically indicates that it has a unique value. Now, we need to assign a unique value to it that allows us to know that if we have a 28 and a 111, it should always be this specific value every single time. No matter what program or what computer it's running on, it needs to be the exact same value of 28 and 111, which has to be within a U short, and also you need to have the positioning correct if you were to untranslate it. So, like, you could add the two together. You could, I mean, I guess what I could do is subtract 28 from the original number and say, alright, then this, just add to get the original number. But then there's no way of saying what that original number is. If you were to put the 28, I think there's a way to do it where we can, like, this is part of the issue, is I have to think of that fact that I have to store the data somehow, but I also have to think of, like, how to do it effectively. I think you could add 111 to 28, but you can't be like, what's the original number? You multiply it by the other number, then you have an original number. But the problem is, integer limits can come into play with U shorts. We have to be very careful with that. Since we're only working with like 2 bytes, it's kind of imperative that we handle these pretty well. That's kind of the concern I have. Of course, we also can put a terminator, like a 1 or a 0, as a terminator to determine what it is. For example, if the original operation was, like, we could, it's called alias, where you take one word and give it or one value and give it a different value. For example, let's say we have 28, right? We could divide the original numbers by 2 for our algorithm, right? We can take the original numbers, divide them by 2, right? 28 and 111 divide by 2, but that removes the actual original value of 111. Like, that's the idea, is to have it reversible, and like multiplication and division provide that pretty well. Although, and then multiply them by like 4, be like, oh, divide this value by, there's no number that's divisible. However, we could store the pattern type in another bit based on, like, my brain's hurting right now, but I have an idea for how to actually do the algorithm on it. It's just trying to detect multiple instances and say that they're all what that's going to happen to each one. And I think we can do an if exists kind of thing. Like, if exists this slice, then it equals that. Why would we need to do that, though? Because they're already unique. We already have a 28 and 11. Boom. That's a 28 and 11 right next to each other. We don't need to assign a unique value to them. We already have the unique value. That's what I'm missing. We have the unique value. It's when it occurs, like, we don't have to compress them. That's it. we have the unique values. So we have that. The only things you want to compress are like double O's. But then it leaves me with more questions than answers, I think. And I still am kind of lost then. Because, yeah, now we have 28 and 111, but, like, That's 28 and 111. That's a unique identifier right here. This is a unique letter. It's not it's not two letters. It's not the letter whatever 28 and 111 correspond to anymore. It is a unique letter because it recurs inside of that. It's a word, as a matter of fact. That's what it is. A word is a recurring pattern inside of this. So if we have, if we're receiving a, okay, so we could initialize. Let's think about this. U short check, and we're receiving like, I don't know. We're gonna take a for loop, right? We're gonna make a for loop to initialize check for each incoming word. Now, what it's gonna do to determine if they exist, or like, yeah, we could take the first number and then we need to create a reversible method of doing this. I don't think there's a way to like append straight to this, append a 28 straight onto that. But we take the first number. What if we converted it to like a float, but then you can't convert it back? That's the issue. You can't convert it back from that. Bitwise, maybe? We need to handle it bitwise? Oh. Brain pain. But we'll have a for loop that does that stuff. Handles that initialization. We're not going to do a for each pairs to append combo, because it's not going to work the way we want it to. And so the first part of this is to create an int called I, and then until int I equals, as long as int I does not equal the incoming pairs length, -1 int, yeah, -1 int, yeah, an int. Yeah, we can create an int, guys. Call it int I. I am the computer, guys. Today I am back to compute today. My brain will fry just like my circuit boards. Alright, so that creates our first loop. Then we need to do if not check. Because I think that's effective enough to get us that if not check statement. So if not check, then append to check. Or no, check equals the pair of pairs. Pairs 1 dot, or pairs of I dot pairs. Use Python instead? Bro, Python's lame. Get out of here. I'm not a Python enjoyer. Python hurts my soul every time I see it exist. It's like the most cringe language besides Java. And then let's see. Oh, besides Lua, actually. Let's talk about cringe languages. Java and Lua, cringe. Get rid of those. Destroy those languages. Actually, nobody would stoop as low as Rust, though. I think we can all agree that Rust is the worst. But D is the best. D is always going to remain the best. Besides like normal C, D is great. D is amazing. C++, I like that too. Let's see if my brain pain can handle the next steps. So we create our check. Check equals pairs of I dot pairs, or pairs at the index of I dot pairs. And then Rust is yeah. See, we can agree on Rust being absolute slop, bro. It's terrible. Rust, it's like Java, but extra worse. It's like Java, but like they got Cheeto dust on it, and it fucking is terrible now. Bash is the best. I can agree with that. Bash has some like C-like syntaxing sometimes. I like it. Bash is pretty good. Bash is really easy too. It's like a fucking, well, I mean, it is a scripting language. Like if you're gonna have a language that runs as a script, I think Bash is where it's at. Like, yeah, you can use Python in the terminal, but why would I when I have Bash? Got Bash right here. But you know, Rust is fucking shit. PowerShell is better. Like if I want to use up 600 gigabytes of RAM to go run my terminal, maybe. If I want to use my entire graphics card just to use the command line, yes, I'd use Windows then. If check, okay, we create check, then we need to create a another array or another fucking loop. No. For each loop, my brain is on the right track, maybe. Pair, comma, pairs, and then we check it against check. Oh, also I didn't quite initialize that correctly. There we go. If the pair equals check, then do the fucking weird spaghetti math that's about to occur at this time. We can't have anything with decimals. That's the biggest restriction we have. So else if do... Oh yeah, we need to do an else if pair does not equal check. Then we redo combo based off of this. No, we would create a secondary. What do we do next? Because we would take else if of that. That would give us a result of some kind. We could append it to combo, but what if we have... God forbid I open up this again, but this is basically the whiteboard, right? So, let me just erase all of this garbage, this terrible explanation of what we're gonna do today. So if we have, like, for example, let's take the one we originally had, but then let's say we have two different types, right? And if we do what I was thinking of doing, where we append it, things are, I think everybody already knows, but I'm just doing this for me, for fun, so I don't really care. I think most people already know what I think I discovered. So we have 1 2 1 2 6 3, and then we have another one where it's also 6 3, and then we also have one that's 1 2 again. So we have like an extra one. Obviously, that will append to 0 at the end to create a null terminator either way. And null terminators will just be a separator, basically. But that will also have the potential. So, like, if there's a word with odd ones, then it's going to be like, oh, a 0 at the end. Oh, we need to make a new thread for nothing. But if you don't know how the programs already works, it takes words and splits them based on those spaces. I'm going to use that same concept if I have to handle the files. I'll be using the null terminator to handle the files. Oh, shit. Okay, so we have 1 2 1 2. So, like, this is 1. And obviously, if that's 1, this is also 1. Both of these are 1. This is 1. But then this is 2. And so, if we check for 1, boom, 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 we get to this one. This is not 1. Very, very, very obviously, it's not 1. But it is 2. Is 2. And so, if we append it, doing our absolute fucking amazing art right here, but if we append 6-3 because it doesn't exist, well now, we have to append 6-3 again. Because now there's a second 6-3 to append. So now we have a second 6-3 to append. Right? That's the idea I'd come up with. So we don't want that to happen. And we don't want to have to check that there's 1,000 of these indexes at the same time. But we could append combo with make a combo an array of arrays and append a 6-3 to it. There's always that option. So that's why we can't do an else if that appends it. Then we'll save it to an index, basically, or a has not checked yet. So we'll call it a U short for, or actually it would be a, where did I create it? A pair check array. Append it to a pair check array for did not check yet. And it has to redo that, but that's the thing. We'd have to, let's just do it to the original one. So, we're trying to build combo from the original pair check array called pairs. So we'll just change the pairs index, right? So check if it equals pairs dot pair. That assigns that to that. So if we could completely avoid using combo at all, too. Technically. But I still like having it there just in case we need a second variable for this. Plus, when we go to reinitialize it, we'll use something similar to recreate the word immutable. And then send it. That's essentially what's going to happen, because once we put it into BPE, it will be sent to main, basically. There'll be a function used in main. Alright, so pair equals check. If pair equals check, then do the math. So we'll do // math so I remember what I'm talking about. Because I know I'm not doing that right now, but it is there. And it's going to become an array of 3? No, because it handles it by 2s. Can't be an array of 3 if it handles it by 2s. Well, the next level of it will be, the next level will be 3s, and then 4s. So I think the longest words are like 4 letters long. 4 to 5 letters even. Like WHICH is which contains WH, which is common. Like for, oh, let's go ahead and explain what I'm thinking of. Yeah, let's explain for like the next 5 hours. Like, I would be a great professor for this stuff, probably. Alright, so we have the letters, which. Oh, I forgot the H there, my bad. But you can see that WH appears in what. So obviously we want to select what, and WH is a common factor in those two. WH. And then we also have CH, which is common with cheese. And so we want to take CH because it's a subword. And we also have E, or that. EE, which is a common word inside of that. And we want to give those their different values, like this one's Z, and this one's X, and this one's L. And, you know, AT is a common thing in... Well, after that, we wanted to start being like, well, where else is there AT? Well, that has AT. It also has TH, which is common in the. So that's common. Right there. So then we have AT, which we can assign to like... I mean, then, but the problem is... That's the problem. We need math to create the actual identifier. It's way easier to compare, like, the number, but, like, oh my god, bro, I can't use floats or anything, so I can't do any of that stuff, and I can't use multiplication if I don't want things to explode, so, unless we multiply it by a known number, right? Like, if we multiply any number by 3, right, for example, we can just divide it back down by 3. So even though there's two numbers there still... But then it's if we do a combination of different techniques to get these letters out and assign their different IDs. So here we do the for each pair of pairs, and then we do our math. If pair equals check. Math, let's go. Yeah... We love math? No. Please, no. But then we would need to do a for each of pair? No, wait. If pair equals check. Then we don't need to check if it's occurred multiple times. Well, in some cases, hold on. In some cases, you might have, like... Let's get rid of all of this fucking garbage. But, like, let's say I have, what again. Like the word what. We have WH, which is common, but A and T could be separate, for example. Like, those could be two different ones. It could identify that as 1, 2, and 3. Whereas, like, in the word... Where? Obviously, you need to train such a tool over multiple different ones. RE is a common ending, though, too. But it's not common with this set right here. If you just take what and where, the commonality is just WH. That's the only thing they have in common. So it's 1, 3, 4. For example. Obviously, I treat EE as literally a character of itself. For example, if we have EE, like, as in C, then that's going to be treated already as its own character. Like, it doesn't need any extra steps to identify that. That's the thing, is that if you're trying to go for pattern-based recognition, no, that doesn't work well. I don't think pattern-based recognition is effective in such a case. I think recognizing it from an initial dictionary of what these are supposed to be is more effective, but that means I have to self-write it. It needs to be able to write itself, which is where my brain starts to disconnect. I think a lot of the case is in that. We'll just put a question mark there, because I don't even fucking know what that is. Ooh. But yeah, it should be able to identify 1, 2. Then it should reiterate through what it just read to be like, is this correct? I'm thinking because there's like such a big egg, like overall, we're gonna eventually have to have a big loop, like a master loop that's like, is this ready to exit or not? And if it's not ready to exit, then go repeat this step until it is ready to exit. But the problem is that doing that, it's just a fucking pain. Massive pain. Because then we have to have, like, so we'll go to main.d. We'll have, like, this function handle that. Then it goes into a loop, which handles the next function. So every time it gets the return result, if the return result isn't checked, but it needs to be checked against something to make it where it needs to be, like that. Now my brain is not working. Like this byte pair encoding stuff. Like it's easy to make e to a single type, but trying to make like the entire thing into different known values and then re-reference those later, I'm starting to lose what I'm trying to get with this. However, we had a good idea with I had a good idea. If we append, we can use, hold on, let's go ahead and zoom in so I can see better. So if check equals that, right? Then we can increase a counter and store that in there. Then the next problem is doing this for each of them. Probably doing a for each, doing this inside of the for each loop. So then it is like for each of these, then start this process. I think that would work. This just handles that. Then we can take a count. And if it's common, so greater than 1, then we can apply math to the number sent as it's common. And then recheck the entire pair check. And go and assign that value based on known inputs. I think that avoids me having to make some kind of fancy dictionary of some kind and helps me think about it easier. Check is going to stay there. Combo is going to get out of here. That means it will live in your RAM unless you find a way to save it and re-reference it. Which I might do. So that's the check portion, right? That creates the U short for check. But we're gonna do that. I think in a for each loop. Or do we do? Yeah, I think we do it in a for each loop. So you would do for each pair of the pairs U short checks, and it will do that. Then we can hit this arrow, hit enter, and then select from here and tab, boom, and then select here again, and tab. And I think this gets us to our algorithm that I'm looking for. So if check pairs I dot pairs, yeah, English, please. But U short check holds that. It's going to recheck it each time. And if it finds that, then we need a struct in structs.d that will handle this. Struct finder. Why not? Make it easy to understand what it does or what its purpose is. Finder is going to be the tab. It's going to be a ushort, a pair ushort dynamic array, I guess. Why not? And then a pair, or no, a number, or a count. Yeah, do a count. Well, int count. Kint count. Bro. Int count, and then ushort pair. That way, we'll be able to identify them. It will save a unique pair into there. But it needs to be associative array. So, I think you would do an int too, for example. So then you can be like, I don't know exactly how to use that, but I think that works, kind of. Wait. Well, if we're gonna do that, we might as well just use a fucking associative array anyway. Well, no, we need an array of those. Because these are counting how many times they exist. So they need to be a array of pairs. So, yeah. That is how it's gonna need to be. Pair check, pairs. Bro, that we've built a temple of scope. It's the temple of scope, bro. Nobody is ready for the temple of scope. The scope templar. Or the scope temple. Bro, temple of scope. Oh my god. It's a whole function down there. Oh, but wait, it gets better. I'm pretty sure there's one that holds all of these. Oh yeah, called void main. That's what it holds. Everything. Bro, the lines are insane too. Whoa! Whoa! Pain! Insane in the membrane. Why is this if... Why is the closing brace for this right here? Why isn't it up there? Why is this down here? Huh. Seems a little bit strange. That's where it's supposed to be. So wouldn't that just be on the same line with the rest of them? I'm kind of confused now. Why do I always keep them like fucking floating in the air? I mean, I guess it makes sense. It makes sense. I'm not gonna question it. I am not gonna question it. All right, we have our check, we have our pairs, we have our other things, and all of that good stuff. All of that jizz. For each ushort check, if check equals pairs. What did I say we're going to do? So we're checking each of these, and then we're assigning a value to the struct called finder. So that means for each, it needs to count them as well. If not check, then do that. Okay, then every time it reiterates, it sets check to nothing. Perfect. Then we need to do another one. No, it can go in the for loop, right? Yeah, so if check does not have a value, it just sets it to that. If we take the next one where it's if check equals the pair dot pair, then we do this portion and we assign something. We do something. Oh, we count it. So we'll take an int called count. Make an int called count, I think. Yeah, do the int count in here so it reinitializes. Int count equals 0. So we're going to take count and we're going to use that to count the number of times it occurs. So if check equals pair.pair, then we can do count plus count. Plus count. When pairs.length is met, when that is met, we're not even extending past it. So once it reaches pairs.length, it's literally done. Then we will take all of this and put it onto our this thing, our dynamic array. So we need to initialize a dynamic array using count and check. So the dynamic array is a ushort array with an index of int, I suppose. And then, yeah, I think that's how that works. So we'll make we'll auto our found equals finder, and then the struct or the array on it is going to be the pretty much we've just made a 3D array almost, because it's, I mean, well, we could technically make a 3D array, 3-dimensional array using an array inside of, bro, there's an AI programming language where it's like you can, it's really old, but it's like you make like what is it called? Arrays. It's literally just fucking arrays. But it allows you to store words in those. It's pretty interesting. I read about it. It was like really old too. Like 1980s. 1990s or something like that. 90s is when the like 1994 is when the first like byte pair encoding algorithms started to exist. Because there was a guy who made one. I think he made it for like the internet, probably for the World Wide Web. Because there's a lot of tokenization that went into that. Anyway, oh, found is gonna happen. It's gonna happen. You know, pair check dot pair is always fun, but you're not ready for found. Found. And then we do we'd create our ushort first. We'd do ushort, and then boom, then we'll put the int as a int. How do I declare these, though? Oh! Int. Or no, how to declare dynamic array delay. Yes, delicious. This is so yes right now. No, not a dynamic array. Associative. I've been calling it just a dynamic array. We need to call it associative array. Maps strings to integers. Aha! Ha ha ha! Holy shit. Oh, okay. Oh. Ho. Wait, what? Okay, so it does 3 to hello. Hello to 3. Oh, whoa, this is... Bro. This could have been done so much simpler if I just made a fucking massive associative array, stored it in a bin file, and called it a day. Bro, we could just store all the fucking words as its own integer based off of a calculation that the program makes and then goes, oh, hello is the index of this, and it somehow always will get that. Or we could basically use the values of all of the UTF codes and use those to create a randomly generated number based off of each one. Add them all. No, don't add them all together. You don't want that. But then somehow have it be reversible. You need that process to be reversible. But then we can create a unique ID for every single word based on that. However, a lot of the new stuff uses byte pair encoding because you can easily have subwords like, you know, stuff like that. Like ing, er, re, wh, at, th, double e, double o. Those are like letters, like subwords. And that allows you to get context out of a word, you know? Like anything you can use to elevate that word. So you would be like, alright, put my u short in that and have the int be found, kind of. U short in this. I guess we'll just make another u short to simplify this process. Create a u short with an int and then make it equal, or name it found semicolon. That doesn't work though. We'll give it, we'll call it arc, and then we'll be like, yeah, put arc in there. Control S. Arc equals, or no. So the arc associative array at index of the at the index of integer. That doesn't work because it should be an int array. Oh no, you can't do that either. Holy shit. I'm just realizing now that it needs to be like an associative array of arrays, because we're taking a u-short array, and that's not gonna work for this, because we need to store both, so it needs to just be a struct that's initialized with both a u-short array and the int. Like, you can't do an associative array with this. So u-short array called found, and u-short, or no, an int array, int called count. Yes, I like ints, guys. Control S. So that's what we need to do. That's wrong. What do you mean, no? Oh, I know what it means. That's what it means. So we do that, then we do that, and then it's going to equal pair dot something. It's going to equal check and count comma count. We need to be able to be like, if check equals the previous check, continue. So if a check equals the previous check, right? So like we save check to another one called ushort check last, right? Yeah, that works. Totally. Check last. Why did I put it inside of the fucking array? Oh my god. Hell yeah. Check last. Take the check last and set it equal to that at the end of execution of that for loop. Check last equals check. Boom. And then found equals that. And append found to a found array. Find, technically it's finder, finded, or find, and then equals finder, or no, you don't even declare it, you can just be like finder find array. Or you could declare a finder array called find. I think that's actually what you do. My bad. I screwed that up, kind of. Finder array find. Then append found to find, and write find. And that's in the for each loop. So append that to the append found to find, semicolon, and it's done. So then the next step is to go down one, put in a write ln, put in find. And it should return values associated with those. Oh, okay, cool. Look, found 28 and 5. Found those 5 times. Perfect. Found 28, 11, 0 times. Unfortunately. Okay, so 28 and 111, found that, right? So if it finds it 5 times, where is it going wrong? So it doesn't have an if for that, so it needs an if to handle this for loop. Kind of. Yeah, kind of. It needs a if to handle this. Or we do it inside of the parameters of the for loop. So, because it doesn't happen in the for loop, if check equals check last, we can tell that. Does not equal check last. The loop won't run if it equals check last. That means if you have an array of the same thing, it will only do one of them. Which gives you all zeros, apparently. Shit. And check does not equal check last. Well, check last equals that. If not check last, then move that up to there. Let's see if that works. And it needs to work in all cases, so we need to heavily test it to prove that this shit is very reliable. Probably. Because I highly doubt that it's gonna actually work that well. pairs of 0 dot pair. Try that. No, because then it needs to actually enter the loop to begin with. But you can't put it in the loop parameters because if you put it in the loop parameters, it won't work. We've just discovered that. Reason being is that it doesn't have an initial value. Why would we even put check inside of a if statement? Like, there's no point in setting that. If check does not have a value, it should just get a value. Check or check last can literally equal anything. So check can equal 0, 0, or 2, 0. And it gets reset every time, so it won't equal that unless it absolutely does. Now that works. Kind of. Because it then counts again. So it still enters the loop and goes, okay, check equals pairs dot that. If check equals pair dot pair, it still handles this kind of. I think what I need to do is actually put it in this if statement. There also needs to be an if statement down there to handle that. Okay, but we kind of know what we're doing with this. So we don't want to have like 5 fines come out of that, because there was like 5 fines that came into existence because of that. And it's only checking 28 and 111. How that works? Okay. Find, and then found, and then... Well... Ugh. We kind of have a good starting point. Find, found, finded. But we need to be like find last as well. Otherwise, we could just destroy all of this. Check last equals check. It shouldn't enter the for loop because it has an and statement in there. It should check the and statement and go, alright, the last check last equaled 2811. What is check last even when it's initialized? It's a ushort array. So how does it not equal the same value? Like, what kind of logic is that? Check last should equal, right? Like, let's put a right line in here to assess those values and see what it comes up with. And I can do that. If it puts true out, that check and check last are true, paste that in there. That will help me out a bit. True, 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 true. 5 trues in there. And so check does not equal check last, but what do they equal? Check last and check. What do they even equal? Alright, so it's that and check equals 2. Check doesn't get initialized, so it will always end up being true. We need to then figure out why it wants to do that. But that's because check last is getting set to check. Which is bizarre. Well, check last should equal check here. So does it get to this part and just not set it equal? Well, no, because it gets up to here. And that's in there. See, that's got to be out here for the initial one. Ah, that's part of the brain tumor right there, bro. I'm telling you. Future brain tumor enthusiasts at this time. Boom. Then it doesn't return any, it shouldn't return any results because it should be like, oh fuck. We have a 28 and a 1, or 28 and 111. So the first time it was true. The rest of the times should have been false, but it still initialized it and created that alpha check and the other thing. So if that's true, it needs to... And what is the pairs always is that, so it needs to be pairs of I. That's part of the issue, which gave us 95. Finder for 95. So I did not get iterated, or did it? What even happened there? So it was just like 95, 95. False. 95, 95. The first statement it pulled was 95 though. How the fuck does that happen? The first one is 28 and 111. The last one's 95. Maybe it iterates over itself, so it's like increment, iterate over itself. Let's do another one and then write the lines for this as well. We could do that same if statement. So if, and then we copy the check and check last portion of that. Paste. Then, boom. I'm not sure how this is going to break it, but that could potentially break it. Boom. Alright, that creates one of them with a value of 2. Unfortunately, I don't know where the 2 comes from. I guess it checks pair check, and it's like there's 2 of these, but I don't see 2 in pair check. So it's checking, and then it's giving us a 2 value. Okay, so we found a 2 value then. Why is there 2? So it found 2 instances of that? What is I equal in the entire equation, bro? What is I equal to? I. Does I equal 0? Yeah, because I is always initialized here. So it should go and then hits this. I. Count. Oh, well that would mean they would be trying to execute in there. And it should return these. Comma that, and then give me an I. I is not in that context though, so like it's not present there. Can't do that there. So how much does it count to? If check equals pair dot pair, plus plus count. So if that is the case, but what is write ln I semicolon 0, 1, 2, 3, 4 counts 4 times. And it doesn't do it for each word. What about the pair? Put pair first. What the hell? Come on, bro. We ain't need be doing that shit. Alright, so the pair is pair check 28 and 11. Why isn't that being assigned right away? Let's see. So it happens, the assignment happens in, is it before the for loop? Check equals pairs, I of pairs happens in the for loop. But we could just say check equals pair dot pair outside of that, because that would be the same as not doing the I part of the statement, because in the first one it says check, that should be like 0, right? You'd think that'd be the pairs index 0, but no, that's not what that is. Pair dot check equals pair dot pair happens before the rest of that shit. I think that's what I did wrong. There we go. Now we're getting what I'm looking for. So we have a count of 28 and 111, which gave us 5. So 5 for the count, but it's actually 3. 162 and 191, which gave us 5. Finder gave us 5 on that and 5 on the last one. So we've gotten somewhere, because now it's appending every single value to it. Then we do take those from 28 to the other thing, I think, right? Because it's 28, 111, and 5. Problem is it's just counting all of them and going up every time. If check equals pair dot pair, because check is determined right here, that can't be the case. So it means every single pair checks and is a pair of that. But I understand what it's doing. In this case, the idea is to increment it as pairs of I dot pair, because every time it goes up. So then if check equals pair of I dot pair count, that's what it needs to do. There. Got it. I think. No. How the fuck does that not work? Excuse me. So it should have been 0 for the first one, right? So the first index should be the pair check 0, right? What is the pairs of I? Pairs I dot pair. Excuse me, what the fuck is this shit? Oh, right. Do it again, try it again. So then it gives me 28 as a pairs of I. That's gonna have 28 again, 162, 34, and 95. Correct. All of those are correct. What is it comparing them to? If that's the case, that it's all correct, like I need to just figure out what it's comparing them to determine what's wrong. So if check pairs... let's go ahead and put a comma one of these and then comma and then put in a check so we can check what check equals. Returns 28 and 111. Okay. So why is it that when we get to the next one, it only appends 95 to finder? Is it because check last gets initialized first in this? So if check does not equal check last, that should be like the last thing that happens? Because otherwise it just fucking breaks the statement. That's probably it. No, it's not an issue of ordering. If check does not equal check last, right? So what is check down here even? But it doesn't happen inside the loop. Maybe that's the issue. Then the loop also depends on that check last statement to determine if that is the case. However, if you put it in this, no, that does not work. If it wasn't this, then it would work. I bet that will help us get it to working. No. Because now it's producing multiple of them. So if check does not equal check last, why is it getting through all of these? And then it sets it to 0. Because it gets to that last one, it's like index dot length. So I guess you could do minus length. Well, check last will always equal check, right? Yeah. What the fuck is this length? Is the language D exists first time knowing? Tell me about the D programming, please. All right. D is a programming language of a garbage collector. It's like it can be object oriented or you could just completely ignore all that. It's a systems language, I think people call it. And it's amazing for me. I like it. It's great. Me personally, I like D-Lang. It's amazing. But I don't know. I think you're better off learning C or C++ or some other mainstream language than D-Lang. Nobody uses D-Lang, but it's got a lot of capabilities and it's got a lot of cool features in it. You can search up the D-Lang website and there's a lot of good information there about it. Which area do people use this? Nowhere. Hobbyists. It's a language for hobbyists, I think. Although, I have heard it's like... the book for it is also in Turkish. So maybe they use it in... over there. I don't know. How I start the leet code? The leet code? Any tipsters? Yeah, I don't know. I mean... There's lots of good documentation out there. How to start leet code. What is leet code? What do you mean? D-Lang is leet code? Oh. I don't know anything about leet code. I just now heard of that. That's new to me. U short check. Okay, what are we doing again? Where am I at? Still at this problem. No bro, leet code platform? Oh. Yeah, well I found it. Online platform for software coding, interview preparation. The platform provides coding and algorithmic problems intended for users to practice coding. So you want to start the leak code for DLang? Or something? I don't know. No, bro, leak code. Platform search? Yeah, I just searched up the leak code. Let's see what I gotta do next. It's for the problem solving thing. Yeah. So, what about it? How do you start it? Like, I don't know how to start leak code. I never used it. A new way to learn. Just go on their website. I'm sure they have all the information. Bro, they have C++ in there, and it literally looks like DLang, bro. Holy shit. DLang, guys. What is the ampersand doing in that code? Oh, man. I use Fedora, by the way. Oh, I use Arc, by the way. Are you ready to... Arc Linux right here. Oh, yeah. Arc cursor right there. Arc. I use Arc, by the way, guys. That doesn't make me cool, because I don't know anything about Arc. My voice is different? What do you mean? I haven't been replaced by Fish AI yet. I haven't been replaced by my robot yet. It's still a work in progress, because it can't figure out how to count different letters. Well, because I can't figure out how to make it count different letters. KDE got respect. Thank you. Alright, let's see. Int count. Which shell do you use? I use just admit fish. You're rank 1 on leaderboard on leak code. Bro, I'm rank 1, bro. Sounds like you are really tired. I got up like a few hours ago. Which shell do I use? I use Alacrity. Or is it called Alacrity? I don't know how to pronounce that. I think it's pronounced Alacrity. Like Socrates. You know, like Alacrity? It's pronounced weird like that or something. You know, creepers were produced by a coding bug, is what they say about Minecraft. But I think I'm ready to start working on fish tech, probably. Actually, no, I'm not. I'm not ready for fish tech. Bash or ZSH or ZSH. Not terminal. Oh, Bash. I was confused for a second. But why would you use ZSH? Like, why would you use ZSH? Bash. Like, ZSH is like... I don't know. You fish, you need to use fish shell. Should I? Fish shell? Oh, fish shell, bro. Hell yeah. Fish shell. Bro, it's got like ceiling function detect OS. Bro, it actually is pretty cool looking. Fish users / demo fish. Abbreviations. Web-based configuration. Fish shell. Fish's shell. Try it. Oh, so we got these, but then they are like, oh, this is equal to that one? Oh, that's not good. Oh, you know what it is? Figured it out. I figured out the answer to my problem. My problems have been solved. My problem was right in front of me the entire time, guys. Beam, 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 doo, 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 doo. Nice, that works better. Then it should count each one. We just gotta remove this right line because it's fucking annoying. Save that and then /test counts 4 each time. Oh, can we get a count of count? Like, can we write a line for counted? Counted, semicolon. Oh, never mind. Right line count. Okay. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Some numbers. Boom. Count is just 1, 2, 3, 4, 5. Every single time it counts, it goes 1, 2, 3, 4, 5. And it's doing it as 95 for all of them. So it's doing 9595. 9595, bro. It's just checking 95 against itself every single fucking time. What the hell, bro? My brain pain is insane, man. Int count equals 0. Yep, so we create our int count, make it equal to 0. Every single time. I mean, I guess we could declare an int outside of it, but we don't really do that. Check. Bro, this programming killing me right now, bro. ++ count. Then we do ++ count, right line count. Every time we write the line for count, it just gives us fucking that. Because if check equals pairs I, and we probably need to add the part where it says not check. And what is it, like and ampersand does not equal check, does not equal check last, check engine light on. Boom. I'm not sure why that didn't help it work better. Wait, did I DMD it? No, I didn't. Did I? Aha. Redo it. Control S that shit. /test it. Did I do it before? Now my brain isn't working. I mean, theoretically, we could just call another thread that handles all of this. And it'd be way easier to just send out each thread to check against the string. Be like, all right, we need 20 threads for this for this word because it's a fucking massive word. But words aren't usually that long. But if you have a massive word and it takes like fucking forever, many characters to handle that, well then you're kind of screwed. Because then you end up with like bad stuff. You'll end up with a lot of threads going on. Your RAM will be queued and your computer will be about to melt down at that point. So we don't want that. So if check equals pairs I dot pair, then ++ count. Now if the check wait, what if we did like, we've tried two different Oh my god, bro. How the heck does this type of algorithm kill me inside? So if check does not equal check last, then it changes it. So when we got rid of this, well, what if we add an or? Well, this should just be executed at the end. It should just do this at the end of each one, right? Because then it will work. Yeah, why? Then it's never going to actually change. It's just going to be the same. It's just going to be locked in because check last won't change because check last is this. Ah, even better. And are we checking check against pairs of I? Oh, it's been in my face the entire time. Check equals pair of I, or pairs of I. Why is that a bad thing? Can anybody be like, what's wrong with this code right here? Anybody have any idea what's wrong with this code? Take a look. What do you all see right here? Check equals pairs I dot pair. What does that do every iteration of I? Can anybody tell me? That sets check equal to what it's not supposed to be. So what it's supposed to be is check equals pair, and it's not supposed to be in there at all, like whatsoever. It shouldn't even be close to a for each loop, let alone the fucking for loop, especially. This entire past hour was spent on looking at that problem. Now, it counted 2 of those, 1 of those, 1 of those, and 1 of those. And you know what that means? That means I succeeded. That means I have successfully found out how to compare and to get a number of how many is present. So now, going from here, what do we do next? So now we have a count of how many there is. What we can do is create a format, a style, if you will, of how it's going to be handled inside of the code. So when we build our next one for 2s, 3s, etc., 2s are going to be stored as 2s. Obviously, if a pair is storing a 1 in there, like after it, like obviously a 1, and then we have to append a 0. Append 1 comma 0 would be an option, because that would be a way of handling it. So for example, in the case of the 2 17s, we have just a 34 and it has a 1 afterwards. That means if we want to be able to store information about these, we need to have a way of doing that that is effective. But we've got it to work to where it finds those, gets a count, so we can come up with which ones are the most common, or which is common, and then be like, this needs to be assigned to a lower number, or a bigger number, or different, abstracted, needs to be abstracted. Assigned some different value than 28 and 111. And assign that based on that. Probably it's doing some bitwise stuff, but I've gotten some progress with the testing tools, which is amazing. Thank God. Anyway, if you all have enjoyed today's episode, I'll see you all next time.